Good evening. My name is Vishal Sunar, and the title of my presentation is Human Immunity. I have divided this presentation into three sections. First, I'm going to explain section 1. What is infection? Immunity is how our bodies protect themselves and fight infection. Infections are caused by the invention and multiplication of microorganisms in bodily tissue. Infection illness is caused by four major factors. Bacteria are single-celled creatures that cause meningitis and scarlet fever. Virus requires a host cell to reproduce and responsible for infections such as common cold, influenza, and HIV. Fungi affect internal organs and nervous system such as ringworm and candida infection of the mouth, throat, and esophagus. Parasites are organisms that live on or in the host spreading disease like scabies and tapeworm. The method of transmission, as in this diagram, are direct contact. It happens when an infected animal or person comes into direct contact with another infected animal or person. Infections can be spread from person to person through kissing and contact with oral secretion. From infected animal to person through biting or scratching, and from a mother to baby through umbilical cord. Indirect contact happens. It happens when a reservoir meets contaminated surface or things. Insect bites are common source of disease like malaria. And lastly, self-explanatory food contamination. It related disease are caused by tainted food and water. The first two lines of defense are non-specific. The two protect itself against pathogens. The body has three lines of defense. The first two lines defense are not specific. They do not distinguish between pathogens and response in the same way regardless. To prevent pathogen invasion, the first line of defense consists of physical and chemical barrier known as innate immunity. Our skin has three layers. Is the most effective physical barrier against microorganisms entering the body. The epidermis is the skin's outer layer, which is made up of keratin, a cell that makes the skin mechanically strong and impermeable, as well as preventing bacterial growth on the skin's surface. The dermis is the second layer of skin and is made up of nervous and blood vessels. The fibrous stretchy parts of the tissue makes the skin strong and flexible. Lastly, hypodermis is a fatty tissue and made up of lump vessel and blood. Another example of the body's first line defense is mucous membranes. They are found on the surface of the eyes, nose, respiratory tracts, urinary tracts, and other organs. Their function is to filter out potentially infectious agents, virus, preventing them from passing through. Bile, pancreas enzymes, and intestinal fluids all work as a chemical barriers as against pathogens in the GI tract. Chyme helps to eliminate potentially hazardous germs as it travels through the digestive system. Nasal cavities are lined in a thin layer of sticky mucus which helps to capture bacteria before they can enter the body through the airways. The lining of the airways bears microscopic hair-like projection called cilia. The trap pathogens from going any further as they get stretched out either through sneezing or coughing. The second line of defense consists of the inflammatory response, which is reaction to tissue or infection. This is caused by injured cells producing substance that promote swelling, such as histamines, as well as blood vessel expanding and spilling fluid into the surrounding tissue. This is a critical step in isolating the infection and preventing it from swelling to other tissue in the body. The inflammatory reaction is also associated with swelling, fever, and redness. A fever raises the body temperature, allowing cells involved in immune response to attack at a faster rate, causing the immunological response to be faster. Pathogens that attack the body will be unable to replicate as effectively at the high temperature, so the fever has an antibiotic effect within the body. When a foreign body is detected, the body sends large white cell called zygotes to the area. When they consume the foreign body or bodies, they are frequently combined with other proteins such as cryptokines, which aid in the removal of other foreign particles. Third line of defense, antigens and pathogens. Antigens are pathogen components that aware your body that is being attacked. Fat, proteins, and carbohydrates are all the examples of antigens. As down below here, pathogens are microorganisms that cause disease such as virus, bacteria, fungi, and protozoans. It can evade the body's natural immune response, resulting in illness. They are typically transmitted through the skin, bodily fluids, or contact with another contaminated surface. What is acquired immunity? It is a learned response that is formed by life experience and gained over the course of your life. And sensitive to antigens, as we go about our daily lives, we pick up antigens from our surroundings, and our immune system learns from these and develops antibodies to combat them. This is a learned response that will protect us for the rest of our lives. When an antigen enters the body, the acquired immune system detects and devises a tailors against the specific antigen. Our immune system learns, adapts, and it remembers. The roles and type of immune cell and immunoglobulins. Immune cell. The immune cell contains 5 types of leukocyte, also known as white blood cell. Neutrophils are granulocytes that release granules of enzymes to fight the pathogen and are pathogenic in nature. B and T cells are the lymphocytes found in the line of defense. Both are made of stem cells found in bone marrow. Once made, they must mature and become active. These lymphocytes are known to have developed incompetence, which means they can mount an immune response once activated. Monocytes are produced in the bone marrow and account for 5 to 10% of all white blood cells in the body. Ephenolysis, also known as granulocyte cells, play an important role in the elimination of pathogens such as parasites. They also cause inflammation, which helps the body isolate and control the evading pathogens. Lastly, basophils are granulocyte cells that produce histamine and heparin. Histamine, a vascular cause blood vessel near an infection to dilate, increasing blood flow to the infection, whereas heparin is a natural blood thinner. Drug allergic reaction, these cells oversees the immune system, which cause the physical symptoms of the reaction. They produce antibodies such as immunoglobulin G, A, M, E, and D. Immunoglobulins on the bottom down here. These are the chemicals that are released in the phase of the immune response after a B cell has produced the necessary antibiotics, also known as immunoglobulins, against the attack. Each antibiotic binds the antigen without killing it. Instead, it prepares for death. It is responsibility of the other zygote cell that do the killing. Immunoglobulin detects the microorganism and all other cells to identify and combat the threat. Here done as follows. Immunoglobulin A collects fluid in tears and saliva while protecting the body's entire position. Immunoglobulin M. Antibodies are designed to kill pathogens such as bacteria. Immunoglobulin E helps to fight allergies and protect you from parasite attacks. And lastly, immunoglobulin D binds to B cell, assisting the immune response at first process. Self-recognition and tolerance to own tissue and rejection of transplant organs. This is the body's ability to distinguish between itself and non-self. The immune system can learn and accomplish through this antigen. When the immune system first encounters an antigen with the MHC cells on its surface, the immune system does not attack it because it recognizes itself. When the immune system encounters a new antigen for the first time, it attacks it because it does not recognize it, and the necessary immune response occurs. Because the human immune system does not have a consistent response level to foreign antigen. Hypersensitive occurs when an unusual immune response is triggered by repeated exposure to the same antigen. There are four types of exposures to same antigen. The type 1 is an immediate reaction mediated by hemoglobin E antibodies. Anaphylaxis is the medical term for a life-threatening allergic reaction that occurs when a person consumes certain food as meats, gluten products. Type 2, a cytotoxic antibody mediated reaction mediated by hemoglobin G and hemoglobin M antibodies. Blood transfusion is an example of this. Type 3, immune complex mediated inflammation can cause the skin to flare up and show signs of skin abnormality. And lastly, type 4. T cells mediated is a prolonged cellular response that can cause a rash on the skin. And the explanation of the transplantation organs. The act of transplanting cells, tissue, or organs from one person to another to replace the damaged organ with a healthy organ is known as transplantation. The immune system, on the other hand, is an effective barrier to transplant process and has developed effective mechanism to support combat foreign agents. The recipient immune system will recognize the new organ as the distinct body from the rest body tissue, prompting the immune system to launch an attack from and of rejection. Tissue typing ensures that the organ is closely matched as possible, which can prevent rejection unless the match comes from the same identical twins and no two people have identical antigens. The rejection types are as follows. Hyperacute occurs shortly after the transplant when the antigens are detached. And the second one is acute rejection can occur at any point within the first 3 months and all organs recipient have the same level of acute rejection. And lastly, chronic. It's a long-term condition which the body immune system gradually damages the new organ. Specific immune system disorder. Immune system disorder occurs when the body's immune system fails, and this is when autoimmune disease occur. It is which healthy tissue are harmed. There are numerous types of autoimmune disorders that can develop. Another immunological element is dermatography, or disorder in which the body immune system unintentionally attacks the skin, causing inflammation and itching. Next one, the type 1 diabetes developed with the immune system attacks the cell in the pancreas that makes insulin. The elimination of insulin in the sugar provides energy to blood, which is when a person goes into hypo with high or low levels of sugar in the blood. Lastly, multiple sclerosis is another immunological disease which in the body immune system mistakenly attacks the methylene sheath. The covering that covers nerve cells, vision and balance problem, as well as muscle weakness and paralysis are all possible signs. Categories of acquired immunity. As we all know, acquired immunity develops over time. This is further subdivided into active and passive immunity. Active immunity in our body responds to disease it has encountered over time, whereas passively immunity in antibodies we obtain from somewhere else. We can acquire immunity in two ways, naturally and artificially. Naturally, immunity occurs when antibodies are self-developed by the body in response to disease or infection, whereas artificial immunity occurs when the body is purposely exposed to a latent version of infection to generate antibodies ahead of time. Both types of active immunity develops over time but often last a lifetime. On the other side of the immunity is further subdivided into natural and artificial. Natural passive immunity refers to antibodies obtained by the placenta or our mother's breastfed milk, and it serves us well for the first 6 months of life. Antibody obtained from medically are artificially inactive. Antitoxin and antivenoms are the common example of this, as they neutralize any toxin or venom we may encounter. Passive immunity, unlike active immunity, works quick but not precise long. Herd immunity and vaccine programs. Herd immunity is a scientific terminology used to describe the point when the population is protected either by enough people getting vaccination or people having developed antibodies by having the disease. During the COVID-19 global pandemic, there was the highest mortality rate globally in England. The proportion of death involving COVID-19 was highest in April 2020. Hence, the vaccination program were started when the vaccination was confirmed. Everyone was encouraged to participate in the vaccination program to protest the spread of infection to themselves and those around them. Herd immunity could protect the population from the disease, including those who cannot vaccinate it, for example, newborns and those who have compromised immune system. The immune response to vaccination and factors affecting vaccine intake. The immune system capability to respond previously encountered pathogen is known as immunological memory. When a pathogen is encountered for the first time, the primary response is to respond. For the B cells to begin tackling the problem, it takes time for them to identify and locate to appropriate antibody. Despite the benefits of several factors can affect vaccination intake, vaccination hesitancy due to the religious reason, fear about the possible risks. When the proportion of the vaccinated people in the community is below the herd threshold, infectious disease such as COVID could continue to spread. Likewise, the successful vaccination program in the UK, with more than 44 million people vaccinated, there was a serious but rare concern that there is a risk of blood clots and unusual bleeding after administration of COVID vaccine AstraZeneca. Benefit of vaccination. There are several benefits of the vaccination. It can prevent the spread of highly infectious disease, which can lead to a serious health problems and death. It is estimated that since the measles vaccination was introduced in the UK in 1968, about 20 million measles cases and 4,500 deaths has been averted in the UK. Similarly, in 1940, it was noted that around 4,521 notification and 857 tolling deaths were identified in comparison to 698 positive cases and 1 death in 2020. In addition, all report deaths has been informed into individual who has not received vaccination against measles. This pointed out the benefits of vaccination as it reduced the morbidity and mortality rate against various diseases. Likewise, in COVID-19 global pandemic declared by the World Health Organization had killed millions. Since the coronavirus was an airborne disease, it spread through the areas suspended in air such as talking, coughing, etc. The vaccination was recommended for everyone, including pregnant women and children until the age of 5. Not everyone was vaccinated due to various reasons such as risks of side effects, religious belief, and personal opinions. Thank you very much.